All right, hello, math people. We have another lesson in our expressions unit, and this one is about combining like terms. So if you don't know what like terms are, or if you don't know how to identify like terms, you should go look for the lesson that describes what those are and how to find like terms. This one's going to be about how to combine like terms. So why even talk about like terms in the first place? Well, because you can combine like terms, and that's another way that you can simplify an algebraic expression. And here's how you do it. Um, I wrote out a lot of stuff here, but let's ignore the words for now. Um, like terms can be combined together. And what you're going to be looking at is the number that is in front of the variable. That's also called a coefficient. And you're going to be combining like terms by adding or subtracting the coefficients, the numbers that are in front of the variable. And when you combine like terms, when I put two like terms together or three like terms together, the variable part of the term, what I have called the last name, so to speak, that never changes. That always stays the same. So if I'm putting 3x and 2x together, that's going to stay x. So 3x, let's say that we had a simple expression that said 3x plus 2x. You can combine those together because they're both x's. They're both in the same family. They're like terms. And the way I think of this sometimes is replace the x, the variable, with just a word like apple. 3 apples plus 2 apples would be 5 apples, right? Or use the last name analogy. 3 Carapezza plus 2 Carapezza, in total that's 5 Carapezza. The last name part of it, the variable doesn't change. So it doesn't become like x squared or something weird like that. The variable always stays the same. And the other important thing to remember is when you are combining like terms, you're always going to work from left to right in your expression. And the other thing I wrote here says you're going to use the operation that is directly in front of the term you're working with. Now, that might not make sense just reading it all, but if we put it into practice with an example, I think it'll make sense. And that's what we're going to do for the rest of this lesson. We're going to go through a couple example problems. Here's our first one. 3x plus 9 plus 2x minus 5. So the very first step is to take some time and identify the like terms that are in the expression. I see two sets of like terms here. One of the sets would be 3x and 2x, and the other set would be 9 and 5. Now, to combine like terms, to put the terms together to simplify the expression, you're going to work from left to right. So that's this way, left to right. The very first term in this expression is 3x. And I know that it matches with this 2x here. So I'm going to temporarily just cross out all the other stuff. Just kind of pretend it's not there. Mentally block it out. I'm going to actually block it out since I can cross it out. So all that's left now is 3x plus 2x. You'll notice when I circled this term, I also circled the plus sign that's in front of the 2x. That's this part of my notes. Use the operation that's directly in front of the term. Just in front of this 2x, right in front of it, is a plus sign. So that plus goes with the 2x. And now I know that to combine 3x and 2x, I am going to add them together. 3x plus 2x is 5x. 3 apples plus 2 apples, 5 apples, 5x. If that was a minus sign and I had put a box around a subtraction sign instead of an addition sign, then I would be doing 3x minus 2x, which is 1x. And we will look at an example that has that. Actually, the other terms in this expression have some subtraction. Let's look at those. So in the other terms that were like terms, I'll circle those again, were 9 and 5. And just in front of the 5 is a subtraction sign. And since we're going to read this from left to right, like this direction, this would be 9 Let's cross out this other stuff because we already used the x. So 9 minus 5 is 4. So what's left here? Plus 4. And this new expression that we have formed is equivalent to the original expression. 3x plus 9 plus 2x minus 5 is the same exact thing as 5x plus 4. Both of these expressions mean the same exact thing. If we said x equals 1 and we plugged 1 in here and evaluated this expression, we'd get an answer. And then if we took the same thing, x equals 1, and we plugged it into here in this new expression, and if we evaluated that, you know what? We'd get the same exact answer. And that's because these expressions are equivalent. They mean the same thing. The difference between them, you'll notice, is the first expression here has 4 terms. 1, 2, 3, 4. And this one only has 2 terms. This is a simplified version of the original. We have simplified an expression by combining the like terms, putting the terms together. But the only way you're going to get better at this is by practicing, so let's do a couple more examples. If at any point you feel like you are getting the hang of it and want to try an example, just pause the video, try it yourself, and then unpause and see if you get the same thing I did. But example 2, y plus y plus y. So step 1 is, are there any like terms? Of course there are like terms in this expression. All of these terms have the same last name, y, so they're all like terms together. And anytime you've got a variable by itself, the coefficient, the number in front of the variable, is a 1. So this is 1y plus 1y plus 1y. So this is super easy to combine. This results in 3y. So I can rewrite 1y plus 1y plus 1y as 3y. These things mean the same exact thing. Pretty simple. Let's do a couple more. We'll do 2 more. Now, here is one added bonus piece of notes you should be aware of. All right, so I skipped ahead and I wrote out what I wanted to say. If you ever see the distributive property within a problem, that means if you see something in parentheses that's being multiplied by something else, like I see right here, 2 times this thing in parentheses, that's distributive property. Before you go hunting for like terms to combine, do the distributive property first. You have to get rid of the parentheses before you can go and start combining like terms. If you try to combine like terms before you've done the distributive property and gotten rid of the parentheses, it ain't gonna work out so nicely for you. It's not gonna be correct. It's not possible to do. You have to distribute first and get rid of the parentheses. So in this problem, I'm going to follow that advice. I notice there's distributive property. I'm going to do it first. 2 times z and then 2 times 5y. So that would be 2 times z is 2z minus 2 times 5y is 10y. And then the 7z I didn't use yet, so I'm just going to rewrite that part of the expression. Now I can go hunting for like terms, and obviously there's one pair of like terms. 7z plus 2z. Left to right, 7 plus 2 is 9z. And then the minus 10y, we didn't use it. I'm just going to tack it on to the end of the expression. So 9z minus 10y is the simplified version of this original expression. And it might not seem like a whole lot just happened, but you went from something that had parentheses, distributive property, multiple terms, multiple operations, down to 9z minus 10y, a simpler expression that has 2 terms, much easier to look at. And remember, they're equivalent. They mean the same thing. So the last one we're going to do, look at this big bad guy. Looks bad, but we can do it. The first thing, though, now that we have this rule that I wrote in red up here, if you see distributive property opportunities, do it first. You have to get rid of parentheses where possible before you combine like terms. So I'm noticing the very first part of this expression actually has some distributive property. So let's do that first. 2 times g squared is 2g squared. 2 times 3 is 6. And then we can rewrite the rest of the expression, and then we can go a-hunting. Go hunting for some like terms. I am going to color code this so it's easier to see. 2g squared plus 4g squared, those guys go together. 6 minus 2, those things go together. And then lastly, 5g minus 3g, those go together. So now that we've got the distributive property done, we've identified the like terms, now we can go about combining our like terms. You always work from left to right. So the first term, 2g squared plus 4g squared. I'm adding them because of the plus sign that's just in front of the 4g squared. So 2g plus 4g squared is 6g squared. I'm going to cross those terms out since we've used them. They're done. Working left to right, the next term is 6 minus 2. 6 minus 2 is plus 4. Cross those out. And the last term's 5g minus 3g is 2. 5 minus 3 is 2. So plus 2g. And that, my friends, that little expression right there is the simplified version of this big old ugly expression that we started out with. Both things are equivalent. They mean the same thing. I know I keep repeating myself, but I just want to make sure you know that this new expression and this old expression are the same exact thing. And that, in a nutshell, is how you combine like terms to simplify expressions. Sometimes there's distributive property present as well, and just make sure you tackle that first. But you can do this. It's not a bad skill, but it's a super, super important one. So take your time, do the practice that you need to do to get good at this. This is a skill you're going to use in every math class from here until you're done taking math classes. So put in the work to get good at it. If you have questions, let me know. Otherwise, happy mathing, everybody.